All right, so in this one, we're told that the velocity in meters per second of a moving body is given by this equation, 50 minus 10t. And we're first of all just asked to find the acceleration. So the thing to know is that, velocity is the derivative of the displacement, right? Or distance, or position, depending on how what the problem is. And then acceleration is the derivative of velocity, right? So this is just asking what's the derivative of this function. So if we take the derivative of this function, we get derivative of constant is 0, and derivative of minus 10t is just minus 10. So our acceleration is negative 10 meters per second squared. Okay, or so remember, so here we're taking the units of the velocity divided by the units of the time, which is the variable. So you get meters per second squared. All right, the second, so this is acceleration. All right, and then the second part of this question is asking, says the initial displacement is 40 meters. Okay, so we're starting at 40 meters away from some reference point, and we're asked to find an expression for the displacement in terms of time in seconds. Okay, so now, so remember the velocity is the rate of change of displacement over time. All right, so if we were going to go backwards, right? So we want the antiderivative of the velocity to get the distance. So I'm going to define a function d of t is equal to the integral of 50 minus 10t dt. Okay, now that's just a polynomial, so we can easily integrate that. So we get 50t minus 10t squared over 2 plus c, right? Don't forget your plus c for your antiderivative. All right, that's your antiderivative. Now I could cancel this and make this a 5. All right, so now we want the actual, we don't want anything in terms of c, we want just in terms of time. So we want to get rid of that c. So let's evaluate it. We know we're given that the initial displacement is 40. Initial means t equals 0, right? So at t equals 0, if we plug that value for t in, so that becomes 0, and then we have minus 5 times 0 squared at plus c equals 40. Okay, so everything goes away except c. So that's telling us that c equals 40. And then, okay, so we can write our final equation then, since now we know c is equal to minus 5t squared plus 50t plus 40. Okay, and that's our equation for the displacement.